Hello, my name is Lucas. I'm from the internet. You can find me on GitHub. You can find me on Twitter. You can find me on Facebook as well. Don't use email. I'm here to talk to you about code style. So obviously everybody agrees. There's no controversy, so it should be an easy talk. First, we're going to talk about why we would like to code format at all. Why do we need all the formatting? Aren't we better at formatting manually? That should probably be something that, everybody knows how to do, right? Like we also can do way harder things. So just, putting spaces or not putting them, it should be relatively trivial. Then we're going to talk about how we can actually write reliable tools that mutate source code in ways where the source code still behaves the same after the tool was applied. That was kind of one of the main tenets of writing an auto formatter that people can trust. So finally, we're going to talk about how I chose to implement my own auto formatter. There's obviously many ways to do it. There's only one way to do it correctly. No, I'm kidding, but this is how I did it, and I'm just going to explain to you how I did that. And then obviously fun problems, because life never kind of, is boring. There's always stuff that happens that you didn't quite predict. But let's start right at the beginning. I have a friend. That friend lives in Boston now, Jack Dietrich. He's a core developer, and he likes to say that code is the enemy. Right? He used to say that he hates code, and he wishes there'd be as little of it as possible in his projects. And he's right. Code is complexity. Code is something that we need to maintain. All the bugs are there when there's code. No code, no bugs. So given that, we should agree on having code that is as clear as possible. And so we have code style. What is it? Well, code style is an agreement between people on a team, right? Because otherwise, there is no meaningful reason to have any rules if you're not going to share your code with other people. One of Guido's key insights very early on was that code is read much more often than it is written. So code style here is very important in the sense that it aids in reading code. For example, during code review, right? A code style should decrease the number of round trips the author of the change and the reviewer have to make to agree on a change that can be integrated, right? So we should remove noise. We should make the diffs as small as possible. That way we actually aid the process of maintaining software, the process of developing software. But also a team of one in time needs a code style so that you are not surprised more than necessary by your own code in 6 months or 16 months or 60 months from now. So maintaining a consistent code style makes it transparent. You can focus on what the code does instead of saying, I really used to kind of, format this thing differently than I use now, and it kind of makes you miss the forest for the trees. So fortunately, with Python, this is a solved problem, right? We have PEP8. PEP8 is kind of wonderful. It helped the community a lot, even though it was created as a style guide for the Python standard library. And it was created in time. In fact, that was in July 2001. So there are a number of standard libraries that are still there that predate PEP8. So they don't quite, comply with whatever PEP8 says itself. But obviously, PEP8 starts with saying that a foolish consistency is the hobgoblin of little minds, and there are more important things than, just making sure that all of the code in a million-line code base project look the same, especially if they predate the PEP. But PEP8 became so popular that suddenly we started seeing its use in external projects. So what makes PEP8 so special? It says that a style guide is about consistency. The consistency with this style guide is important, with a project is more important, but within one module or one function is the most important. However, if you look at PEP8, it itself provides multiple ways to do things. It says these are the acceptable ways. Sometimes it would say these are the not acceptable ways. You should prefer, right? It's more of a style guide than a code style. So in that sense, it's kind of a framework for creating your own code style for your project within your own team. So to get from a style guide to a particular code style, you have to settle on a subset. You have to decide that, no, okay, like we're not going to do this part, or we're going to choose this way of doing things and not others. And how do you settle on that subset? Well, you can use documentation, you can use word of mouth, or you can use wiki pages, right? Like wiki is this Polynesian word that means where information goes to die. So people just like put their code styles there, and then they're free to ignore them as well. So we need to enforce the code style, right? So we can use humans for this, which is kind of expensive and not effective and not consistent, but we can. But we can also use linters, right? Let's do it automatically, and let's kind of hit people on the head with linters on CI as well. But linters are kind of not the best that we can do. Human code review for code style and for enforcement sucks. And the problem is that linters suck even more. They slow you down. They increase the round trips you have to do with your tool because it only tells you like what it doesn't like. It doesn't really suggest the fix. And even if it would suggest a local fix, that local fix might be different between particular lines in your project, between particular files. So linters, yeah, like they're only useful if they warn you about things that sometimes could have very dramatic consequences. If they are telling you you forgot spaces around a math operator, like, well, that is just making people annoyed. So how about let's make machines do it for us? Auto-formatting removes code style enforcement from the consciousness of the programmer. If you just use a tool like this on save or as a pre-commit hook or whatever else, you not only not have a linter that slows you down during editing and pull request submission, but also reviewers don't have to comment about style transgressions. So again, that doesn't slow you down. In fact, you don't even have to slow yourself down when you are within your text editor. You can stop thinking about style whatsoever. You can just write as ugly as you want, doesn't matter, because on save, everything is going to be fine again. So the problem is that if automatic formatting feels too destructive, people don't use it. And so there is some insight there that good enough uniform formatting style is better than having lots of different formats. You shouldn't kind of have too many opinions, but the opinions that you do have should be uniform, should be easy to explain, should be trivial. That essentially when a tool does something, even if that is not optimal, you understand why it did so. So the value of the style guide is uniformity, not perfection. The more people think about their own formatting style, the more they get attached to it, and then it's actually hard to improve the situation at all. In fact, this kind of insight comes from the Go community, where the Go formatter was a crucial part of making it feel more productive from day one. And there's other opinionated formatters like Prettier for JavaScript. In fact, I used to work with the author of Prettier on the same floor in my time at Facebook. So our conversations did inform certain things that I used later, implemented later in Black. So how do we actually implement stuff like this? How can Python read your source code and understand what matters, what doesn't matter in it? How do we make source code execute by Python? Well, let's talk about this just for a while and use the actual Python grammar for it. So the notation that I'm going to use is the actual notation from the actual Python 3.7 source code. And so you can actually open the grammar file and see that, this is what you're going to see. So what a grammar is for a programming language is a list of productions, right? So what are the possible syntactic things that are valid in our language? Right? So there are productions that are consisting of several tokens that we just have, provided by us, like strings, like numbers, like new lines. Those in the grammar of Python are always specified with all uppercase words, right? So new line, that's a token that the tokenizer gives us. That means there was literally a new line character in the file. Other productions are just sets, are combinations of tokens and other productions. Those are non-terminal. And those are lowercase, right? So obviously, the most basic one at the very top of whatever is happening is file input, right? There's going to be a .py file. When we read it, it consists of a series of statements and new lines, and an end marker. It's like a fake token that just tells Python that there's nothing else. Like, that's it. Like, we're done. So I would like to show you the entire grammar, like this is Python, but that would take the rest of the talk like easily. The grammar is really big. So let's just traverse one path through the grammar so that we can see like how big it is already. Just one path from the very top, which is file input, to all the tokens that the tokenizers give us. So obviously, we would need to go and see what the productions are. So statement. What is statement? Well, a statement is either simple or compound. Thanks. What is a simple statement? Well, it's either a small statement or a new line, and the small statements might be separated by semicolons. Okay, cool. So what are small statements? They are expressions, deletes, passes, flows, imports, globals, non-locals, asserts. Great. What are expression statements? Let's see another slide. Okay, so they're either test the star expressions, annotated assignments, augmented assignments, and so on and so on. So let's see how assignments look like. The annotated ones are annotated because they have colon and a type. Actually, like it's a bit of a hack because of our parser, like to have test on both ends, like both as the annotation and as the thing that you can assign. That's a small detail. And then augmented assignments are all those that actually use an operator and equals later. So moving on, you have test the star expressions. What are those? They're tests or star expressions, right? You know, kind of the name tells us this much. So what are tests? Tests are operators, right? So you can see that right there in the grammar, we already have prioritization of our operators. This is not something that we check for additionally later. Like literally the composability of operators and which comes first is part of the grammar. So finally, we get to like all the comparison operators. But I really want to see what the expression is. So what are possible expressions? So then you have more possible operations that we can do. And finally, we get to atoms, and those atoms have the tokens. So we have this grammar. I showed you just one path to tokens from the file. So we didn't touch on compound statements like ifs, like while loops, for loops, try excepts, and so on and so on. Like we have not seen classes and functions. The grammar is big. But the point is, we actually use this grammar to parse in files that we have incoming. So how do we do this? Well, you could write a parser manually. If you did that, you would make mistakes, you would have edge cases, you would have trouble actually supporting the entire set of possibilities that are valid Python programs. So instead, we have a parser that is automatically generated from the grammar. There are some technical details that are not important for us now, like Python so far is using an LL1 parser. Guido is lately interested in replacing it with something that would enable us to solve some long-standing edge cases. So I'm kind of excited about that. But the point being, if you have a file like this, it's not very interesting what the file does, even though like it's few lines. But the parser will, in the end, change this file input, this text input, into a tree. That tree can actually be then executed, right? So that tree is going to be abstract. So you're going to see that there's a module and there's a body. Within that body, there's some imports, right? And you see that those imports have like certain attributes of the import. So what are we importing? Where from? Maybe we're using some aliases or so or so. And then you have functions. So there's going to be a special function object for this that again has specific attributes for it. And so on and so on. An assignment is going to be yet another node in that tree, and so on and so on. But the thing that we don't see in that nice abstract syntax tree are just the things that we care about when we write code transformation tools like formatters, which is all the white space. Where did the white space go? Well, Python doesn't need any of that when it executes your code. Sometimes there's obviously significant white space, right? So blocks and whatnot actually tell us, how far a for loop goes. But for that, obviously, if you look for how that is solved, essentially just the abstract objects essentially tell you this is the body, this is the variable that we extract during iteration, this is where we're iterating from. But for a formatter, we actually need a concrete syntax tree that actually has all those details. And for Black, I'm actually using one that is built into Python. It's in the standard library. It is fueling the 2 to 3 tool, which was supposed to aid with the Python 2 to 3 transition. And it does, mostly in the form of Python modernized, which is a kind of like a more generic version of this. So a concrete syntax tree is different. It's not so nice. It's more low level because it does really tell you if somebody used a trailing comma, if somebody used a space or not, and how many new lines were in between. So a concrete syntax tree for the same file would look something like this. There's file input, there's a simple statement. That simple statement is an import, and that import has literally names that are tokens. Import, and then another token that is a name that is prepended with a white space, some white space, and then AST, and so on and so on. If you kind of followed what I was showing you before, you'll recognize that the names of the nodes now are literally the same names as we have in the grammar, which is very helpful. Like looking at the grammar file and looking at the concrete syntax tree helps figuring out whether you covered the entire space of what is possible with the Python programming language at the same time. So the point here is that, okay, it's nice. Now we actually have our white space available for us to transform, even though the tree is kind of more low level, so it's more annoying to operate on. Because, for example, even keywords like import there are just name tokens, just like the name of the import that you're doing. So there's little context on what that import means. It's more of a low-level construct. So all in all, it takes more pages to show you like the entire file, how it's parsed. So I'm not going to do that. Let's just talk about how actually the implementation was done by me. But before we get there, I just wanted to like show you like a little thing that you might have noticed here. Look that there's indent and dedent tokens. So the tokenizer does emit indent and dedent. So if you squint far enough, you'll see that Python, in fact, does have braces. You just don't see them. All right, so design and implementation. How to manipulate a concrete syntax tree, what phases to use, how did we end up with a tool that you can use? Obviously, there's many possible ways to do it. I'm going to talk about the one that I actually kind of approached. So if you're not interested in just listening about like how this is done, but you're just eager to try it out, pip install Black, you can do it now. For everybody else, how did I actually end up writing out a formatter in 2018? Well, that's kind of weird, right? There were already other formatters, and it's also not something that is kind of a direct problem that engineers should be working on. It's clearly yak shaving, some other problem that I had. But long story short, I had some design goals that other formatters were not quite satisfying. Those design goals were that I didn't want a formatter that is super configurable. If you have a super configurable formatter, then you end up moving the bike shedding from the code review to the configuration file, right? So I wanted everything to be formatted the same. That also gives us consistency. So the same rules are applied in all situations. So that makes it predictable to the user. I wanted to be fast. So like ideally just done in a single pass, like to avoid backtracking, avoid dynamic programming, meaning it is linearly getting slower with the size of your file. Right? So if you have Python files that are megabytes big, you would think like, well, who has files like this? Well, Facebook does. So all of configuration of Facebook is actually expressed as Python files. So some of that is obviously automatically generated because you just add layers of abstraction always. You never remove somehow like the abstractions. So Sometimes if you want to format a file that is 2 megs big, well, if you use some more complex algorithms, that will just never end. So I wanted it to be fast. I wanted it to be deterministic as well. So one pass over your file should give you the final result. And running it another time over that same formatted file should never change its mind, right? Like if the tool changes its mind being run multiple times over the same file, well, I considered it a bug. So obviously, these are the most high-level reasons and kind of ways I was thinking about all this, but what about the code style? So I thought about code style like this, that there's 4 fundamental parts of a code style, right? So let's go through them, and like by doing so, like just kind of introduce you to the black code style, which is a subset of PEP8 that I chose for this particular tool. You know, I heard some kind of comments, some nicer, some less nice, that like, who are you to enforce your favorite particular personal code style on the entire community? Well, turns out like the code style that we ended up with is not even my personally favorite, but it just turns out that it satisfies some of the requirements that we had best. So what are the 4 possible, well, 4 fundamentals of a code style? Horizontal whitespace, easy. When to put spaces, when to avoid them. Vertical whitespace would be what tokens to break lines on, what tokens never to break lines on, how many new lines to use, right? How many empty lines to use. Line length, well, so self-descriptive, and consistency. So that the point is, just don't surprise the user, right? Like you should just use trailing commas everywhere. You should normalize string quotes. You should always use the same method for wrapping lines, so that people see like, oh yeah, okay, it all looks the same. So starting right on the left, horizontal whitespace. That's easy, right? For example, you have an equal sign, so that means there's gonna be spaces around it. Put spaces around equal signs in assignment, unless it's actually a keyword argument, unless it's using a type annotation, right? So it's like, even that kind of ends up being complex. There's edge cases here and there. All rules of formatting will end up having some edge cases. Sometimes it's funny because PEP8 was evolving over the years. Sometimes it was just adding more rules. Sometimes it was changing its mind about minor things. So there are things that Black is doing that are conforming to PEP8 that very many people are very angry about because they actually think PEP8 says something else. Because, for example, Flake 8 wrongfully says that Black is doing something wrong. For example, if you have non-trivial arguments on the side of a slice, you should put spaces around them. Like that makes it actually obvious what is happening, that the double colon is slice. If we hugged the D's to each other, but the plus would have spaces around it, that would suggest that something else is happening, that the D's are closer to the colons than the +1 later. It's kind of confusing. So this is in fact what PEP8 is saying. In the document, you can find exactly that example. And I still get, I'm still getting issues file about this. They're like, what are you doing? Well, I recommend everybody read PEP8. Vertical whitespace, right? That's easy. What tokens always to break on, what tokens never to break on? Well, you could put many things in a single line, but like the general consensus in Python is that, okay, if there is a colon, just put a new line. This is easy, right? And then if you have functions, just put 2 lines, 2 empty lines between them. Unless these are methods inside a class, then just put a single one. So all of this is not controversial. The controversial part is the sad face. This is kind of a style that is not like overwhelmingly popular in old code. Like people are like, you know what, like this kind of sticks out like a sore thumb. Like, why would you do that? I like everything else, but like I hate the sad face. Well, I kind of agreed for a week. When you started like formatting code like this, it looks strange, especially that, yeah, like if you have a dictionary, if you have a list, if you have a tuple, you're going to format it like this. You're going to have your opening parenthesis or like any bracket, and you have your closing bracket dedented. But it's that colon that makes it kind of look weird, right? But what that does is it is clearly delimiting the arguments from the body of the function. So it's just a very clear way to see where the arguments end, where the actual fun starts happening. So this is a problem in PEP8, and there's like multiple solutions given for like, oh, you can maybe do double indentation of your arguments. Maybe you can somehow else signal that there is a different indentation level involved here because there's a bracket pair. I chose this one because it's consistent with the collections and it doesn't overuse the number of indentation levels. So that if you have types, so if you have many arguments, if you have long names of functions and types or whatever else, they have the most possible space to fit. I also used a bunch of red here. The reason why is that some measures in black, like the consistent trailing comma here, are only ever possible if you're using a Python version that is new enough. In this particular case, if you did use variadic arguments, either regular ones like here or keyword arguments, the trailing comma is only allowed from Python 3.6 forward. Before, it would be a syntax error, like the grammar just didn't support this. Okay. That's horizontal white space. What about line length? Which one should we use, 80 or 120? Well, neither. We should use 90-ish, which Raymond Hettinger kind of used in his seminal talk, Beyond PEP8. I trust Raymond. He's one of the most experienced Python teachers and core developers. So when he's saying that we almost have what we want, but not quite, because if you have a module and in it you have a class and in it you have a method and in that method you have a loop and in that loop you have an if statement, you have very little space to do anything anymore. So we do that instead. We do 80-ish, 90-ish. Consistency. Let me just give you a few examples. Obviously, trailing commas. We have strings. So which should we choose, single quotes or double quotes? I'll probably forever hear opinions about this now. But I wanted to show you this thing. What is it? Is it an empty string or is it a double quote character? Now you will never know if I don't tell you. So we use double quotes. Double quotes are nice because they anticipate apostrophes. You're going to use them in your strings, don't you? And then they anticipate doc strings, which you already write like this. Unless you're really, really, really opinionated, just write doc strings like this. And it also anticipates interfacing with C, which Python does a lot. And, strings there look like this. So here's the thing. There are some choices. We had to actually choose to do something, and we had conversations about what is possible, what should we choose. Most of the time, the choices were actually informed by stuff like this, like what I'm telling you right now. The point being, we really try to have arguments behind every decision instead of just saying, I like it like this, I don't know why, it's aesthetics. Now, there's actually arguments, reasons behind stuff like this. All right, so what is a line really? The super simplified algorithm that Black is using is this. You're going to create a concrete syntax tree of the input file. You're going to visit the tree, generating theoretical line objects. What are those theoretical line objects? Imagine that there was no line length limit. So we would obviously still put new lines after colons and so on and so on. But sometimes we would just go on as far as we can. So let's do that at the start. And then when a new line is generated and its length is longer than the allowed line length that we decided on, we need to split it. And then for each split, we see whether now it fits the limit. If it doesn't, we recursively split that part again and again. We track blank lines, obviously, because it turns out people are really, really, really attached to their blank lines for delimiting different parts of the function or whatnot. And a line once formatted and emitted is not ever touched again. So we're not going to change the formatting because we saw something in lines below, right? We just keep it as is. So obviously the most interesting part is this. Okay, so like you split lines, cool. Like, but how do we do that? Well, there are two kinds of splits that we're using. Either bracket splits. We can look for brackets on this long theoretical line, either looking from the left or looking from the right. It turns out that except for function definitions, for function signatures, everything else looks better if you're using the right-hand side splits. So you're looking at the rightmost bracket and split on that first, and then go forward. But if you're already in a bracket pair, and it's still, the body is still too long, you need to split by a delimiter. So you're looking for math operators, maybe commas, maybe something else. So the simplified algorithm that includes all of this kind of is longer, so I'm not going to read it to you, but it's visiting the tree, right? How hard is that in Python? Turns out it's actually pretty easy, right? So there's a very common pattern of doing tree visits that I also used. Like, the little twist here is like I actually implemented it as a generator. So the point being, you implement a visitor that just looks for a method of a given node type and then executes that method. If we cannot find a matching method for a node type, we're just visiting the default thing. In use, it looks like this, and this is actual code from Black. You just iterate over things that are produced by the visitor, and you're done. So there are other possible algorithms. Examples include what the app is doing with dynamic programming and whatnot, just to not go there. So fun problems. I'm almost over time, so I'm just going to go quickly through this. Obviously, the most fun problem is users, right? Most users are lovely. They thank you a lot. They report actual bugs. Some users disagree with your choices, and that's fair. It's an opinionated formatter. Some people are offended by your choices, and that's kind of weird. Some people submit unsolicited pull requests and make scenes when you decide not to include their hard work. Some demand configuration, some don't read the documentation. Is always a problem. If your documentation is too long, nobody reads it. If it's too short, it doesn't include important facts there. So open source is a labor of love. What can I say? In fact, when I first rolled it out at Facebook, people tend to love it. They were like, this is awesome. Well, except for one person who was really angry that we have something that is there. So you can decide whether you're the people that like it or not. You can just try it out yourself. In the community, it turns out it's actually pretty popular. It has 4 times the stars than AutoPep 8 has. It has double the downloads that Yap has. So currently, it's weird for me to say, but it's the most popular formatter for Python now. It's actually used by PyTest, Talks, Pyramid, Django Channels, Hypothesis, Adders, Poetry, PyPA applications like Warehouse, pipenv, virtualenv, many others, like soon-to-be Django, Twisted, and Flask. So, pretty much, people like it. There are hard things like implementing standalone comments, so comments that are on their own line. Inline comments are hard because comments are not in the syntax tree. They're just an element of whitespace. So it doesn't say what they are attached to. Sometimes people see a piece of source and they know that, oh, the author meant that this is actually aligned with the line that comes after. But sometimes it's aligned with something else, which is kind of remote to what a given line is seeing. So making this not destructive to people was a big challenge. Optional parentheses. Sometimes if you have stuff in Python, you don't need parentheses. Like, for example, if in an if test. But if you don't, then you cannot split nicely. So sometimes I would put parentheses where there weren't parentheses before. And making it in a way where people don't feel like I'm destroying their code, it's kind of also tricky. So that took me a long time. Sometimes you have a legitimate reason not to allow a formatter to touch on anything. So there's format off. Implementing that was hard, especially across the boundaries of blocks. And making it deterministic, obviously, that was kind of weird. So essentially, is the tool ready for use? Yes, it is. It is very close to a stable release. You should use it. We recently moved it under the PSF organization on GitHub that has a number of other fun projects like Request, so fun company. I'm out of time, but I'm staying here until the end of the day. So if you have any questions on adoption, if you have any comments on the style, or you would like to know more about the code base, I'm either here or you can find me on the internet. Thank you very much.